Hello. In this video, I will be doing examples of inductive and deductive reasoning. So we have the definitions. Inductive reasoning is the process of drawing a general conclusion by observing a pattern in specific instances. So we go from specific facts to something more general. And in deductive reasoning, we use accepted facts and general principles to arrive at something specific. So in inductive reasoning, we can never prove the conclusion. We can just tell that you can just state whether the reasoning is strong or weak. And in deductive reasoning, we use general principles to prove something specific. So these situations are in example 20 are on page 26. First situation, Olivia is calculating what grade she will need in her international studies class to make the dean's list. And this is deductive reasoning. It is deductive because she's using her overall grade. So she's using her overall grade, to calculate her grade in one class. Next situation, suppose that Luis has noticed that the stock market has gone up on the Friday before each of the last 3 holidays. So he plans to buy stock on the Friday before Labor Day to cash in on this trend. This one is inductive reasoning. So he's using specific days, specific Fridays, to arrive to his conclusion that he should invest or he should buy stock. But the thing about the stock market is that it is very unpredictable. So even if that happened on every Friday before the last holiday for many years, that would still be inductive reasoning. Those are still specific dates. So this is inductive because Luis is using specific dates to determine whether he should buy stock. Okay, so I'm trying to type this. This is inductive. It's inductive because he's using particular results to make predictions. And situation number 6. Marianne is using the rules of algebra to solve a word problem on a quiz. This is deductive because the rules of algebra work in general. And he's using those rules to solve a specific problem. Okay, we'll see examples of inductive reasoning. That's similar to the problem-solving strategy of finding patterns. I'm copying the problem. These are still on page 26. I'll copy the directions and the problem. So these are still on page 26. So we're going to do number 13. In the following exercises, we are going to use inductive reasoning to predict the next term in the sequence of numbers. So initially, the sequence is 3, 6, 12, 24, 48. So if you notice the pattern, you are multiplying the previous number by 2. And 48 times 2 is 96. And in number 16, we also have a sequence of numbers. We use inductive reasoning to predict the next term. Okay, so the first terms are 1, 1, 2, 3, 5, 8, and 13. The pattern here is that the next term is the sum of the previous ones. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. And 5 plus 8 is 13. So if this pattern continues, the next term is going to be 21. And one more example of inductive reasoning. We're doing number 27. In the next exercise, I'm only doing number 27. We give you a series of numerical equations. Make a conjecture as to what the next two equations in the pattern are. So check your conjecture with a calculator. So the first equation is that 1 plus 2 is 2 times 3 over 2. The second one, 1 plus 2 plus 3 equals 3 times 4 over 12. And the third one, 1 plus 2 plus 3 plus 4 is 4 times 5 over 2. So the pattern is that the sum of the first natural numbers is going to be the last natural number multiplied by the subsequent one over 2. And we can verify it mentally. 1 plus 2 is 3. And 2 times 3 over 2 is also 3. 1 plus 2 plus 3 is 6. 3 times 4 is 12. 12 over 2 is also 6. And 1 plus 2 plus 3 plus 4 is 10. 4 times 5 is 20. 20 over 2 is 10. The next equation would be the sum of the first 5 natural numbers. So that is going to be 5 times 6 over 2. If you add them, the sum is 15. The sum on the left and the right is 15. And the next one, the sum of the first 6 natural numbers or counting numbers must equal 6 times 7 over 2. So the sum of the first 5 or of the first 6 counting numbers is indeed 21. 6 times 7 is 42. 42 over 2 is, again, 21. And I will finish this video with 2 word problems. One word problem with inductive reasoning and one with deductive reasoning. So I'm copying the problem. That's number 31. So in preparation for his induction into the Baseball Hall of Fame, Derek Jeter autographed a stack of baseballs to give away to his fans. How many baseballs are in the stack? So we are looking for patterns. And that's inductive reasoning. So if we look at this sideways, we have that on top. So we have something like this. So on top, we have 1 ball. Next, we have below that, we have a total of 4. So that's 4 balls. And then below that, you have 3 by 3. So that's a total of 9 balls. And at the very bottom, you have 4 by 4. That's going to be 16 balls. So 4 by 4, that's 16. And if you add them together, if you add all the balls in the stack, that's going to be 1 plus 4 plus 9 plus 16. That's a total of 30 balls. And there are 30 balls in the stack. So we used inductive reasoning to answer the question. And this is going to be the last example in this video, number 40. This is an example of deductive reasoning because we're using hints to answer the question. We're using the information given in the problem to answer the question. Suppose that Jessica, Serena, Andre, and Emily ran for president in the recent student government council election. Determine who won the election using the following clues. And who was the last in the election. So we have 4 students. And they are in the order they gave it to us. That was Jessica, Serena, Andre, and Emily. And well, there are 4 students, so there are 4 places. First, second, third, and fourth. Let's finish the table. Okay, the first clue is that Jessica has been a member of the council longer than the people who placed third and fourth in the voting. So from that clue, we know that Emily is not third or fourth. So we are going to cross it. We're going to write an X and indicate the first clue. The second clue is that Andre finished right behind Jessica and has the same major as the third place finisher. So if he finished with behind someone, we know that Andre cannot be first place. And if he has the same major as the third place finisher, he cannot be third place. Third clue, though Serena did not win, she was happy that she did not finish last. So we know that Serena was not first, but wasn't last either. And fourth clue is that Jessica had 37 fewer votes than Emily. So she has fewer votes than Emily, so we know that Jessica wasn't first. And with that in mind, the first place went to Emily. And we have another question, who finished last? So who was last in the election? So we know that Emily was in second place. We know that for sure. And any more information we can gather from here? Okay, let's go back to the second clue. Andre finished right behind Jessica and has the same major as the third place finisher. So right behind Jessica, and Jessica wasn't number 1. And I want to be completely sure of this. Okay, so if he finished right behind Jessica, and Jessica was in number 1, we know that Andre cannot be number 2. So yeah, so Andre cannot be number 2 because he finished right behind Jessica and Jessica didn't win. So Andre was last. And we don't know what happened with, we don't know who were the third and the second place, but we know for sure that Emily won and Andre finished last. So these are the examples on the second section in chapter 1. Thank you for listening.